who has come over here. I welcome you, sir. I extend a warm welcome to our Vice Principal, Mr. Karthikeyan, sir, and our R&D Coordinator, Dr. Mohanasundara, sir. We welcome you, sir. And also, I welcome all students who are very eager to learn about embedded system technologies. Okay, thank you.
Good morning to one and all. It gives me immense pleasure to welcome our chief guest, Mr. E. Karthik, Senior Software Engineer at NCL. Welcome you, sir. He has a work experience of 5 years as embedded engineer and worked in SIFP engineering and course technologies. He also worked in ITCC Malta as a junior electrical engineer and also expertise in design and development of embedded-based applications. Welcome you, sir.
Now I invite our Vice Principal, Mr. Karthikeyan, sir, to greet our chief guest, Mr. Karthikeyan Vlsi, with a bouquet. And also I request the R&D Coordinator, Dr. Mohanasundara, to join me. Now I request our chief guest to start the session.
As they introduced me, and I think they said my experience wrongly. I got around 7 years of experience in embedded systems. And I worked with, initially, I started with a startup company, it's a project center, and then I later moved to an MNC. My first MNC is Bosch. And then I worked there for 3.5 years as a senior software engineer. And now I'm working with HCL Technologies. Here I'm working as a lead engineer. And I'm just managing 5 people under me. Technically, I'm managing. Okay. So, can you hear? One here. Second? Fine, okay. I'll just take my work. Okay. Do you want me to come back again on that? Okay, thanks. Okay. So, today, we are just going to see embedded workshop. So I bet you that this class will not be a normal workshop. As you ever, I don't know whether you have gone a workshop already somewhere before, or you have gone outside or an internal. This class is going to be a little different. So I just want to know which year you are. Third year. Okay, you are perfect then. So you will be starting your project by next year, obviously. So this workshop is going to be an hands-on practice. Can you hear right? Okay. It's going to be an hands-on practice, and it's going to be kind of self-experiment. Not from me. Okay. Each one has to go deal with dedication, so that you have to learn the embedded engineering, and then I'll just explain you what is embedded engineering, what is the scope for embedded engineering, what it will be the how to get an embedded engineering job, and what are the fields of embedded. How you can just go next in embedded. And okay, having said that, I just want you all to stand up for 1 minute and just be still. This is for so just 1 minute. do you expect out of this class? Just 4 things. Name, department, forgot the word, right? Year and what do you expect out of this class? Okay, start. This is a very, whoever have an idea of entrepreneur, please understand this thing. Whoever have an idea to open a business, just concentrate on this particular thing. Okay? Simulation. This is one of the highest business yielding part in anybody. Okay? But the question is, what to simulate? If you come into the thing. So I'll just share my experience. In the Bosch, we can't just test our codes in the car. Maybe if I do something wrong, my car is going to crash, and I work for BMW customer. If I crash, I have to pay 1 crore or something. It's for German company directly. We work for German cars. So what the client, the BMW given us is, we have given a big, you can imagine like a bureau. It's like a complete, this much big, and we will just connect our ECU. It's a separate, we can just connect and disconnect to that particular machine. Okay, we'll just connect to that, and that particular thing will simulate everything of the car. You can simulate a brake, you can simulate a rough road, you can simulate a turn, steering wheels, you can simulate what else, wipers, you can simulate engine speed. Everything will be controlled by that particular machine. This is again an embedded thing. So you can simulate everything into that, any environment. Say for example, coming to the same medicine thing. Okay. So for example, if I'm just putting my system, keeping an my intention is to check my algorithm, my board algorithm. My board algorithm is nothing but if X is there, give it to X1. If X1 is there, give it to Y1. If X, then do X1. If X1, do Y1. If Y1, do Y2. This is my algorithm. Okay? Algorithm is not max, don't fear. It's just like understanding the flow. Algorithms are confirming how your system is going to behave. Say for it, okay, I'll take a washing machine, that is this. If water is there, I'm going to spin. Okay? So I should spin 10 minutes. Okay? Spin X1 for 10 minutes. So if 10 minutes over, do Y2. Flush the water and refill. Okay? If I do flush the water and go for dry. This is my algorithm. Okay? Here, say my condition is I should not use water. Okay? I should not use detergent. But I should simulate it. Okay? I should not use the real, I don't have real washing machine there. I have only the board, and they are given a small kit or something to test it. So I should not use the water or clothes or detergent, but I should simulate. How do I simulate? We know the principle of working. If it finds the weight equivalent to some X, it starts spinning. So what we will give is, we will give the, usually this weight will be reading through ADC. How many of them know ADC? Answer. I should know the volume. Very less. Okay. ADC is a kind of analog to digital converters. Okay. So any analog signals will be converted into zeros and ones. Say for example, if this is my analog signal. Okay. This is my analog signal. When I bypass it to a ADC, I will get 1 for this, 0 for this, 1 for this, 0 for this, 1 for this. So 1 0 1 0 1. Any doubts? Any doubts? Clear? Okay, fine. Okay, so you are clear, right? So this will be your analog signal. Nothing but there is no digital signal in nature. This is a worldwide theory. There is no digital signal in the real world. Everything is analog. So in the embedded, we have to convert them into digital, keeping some certain like this. If go high, put it 1. If go low, put it 0. Or if my voltage is above 5, then only make it 0. If it is below 2 point, if it didn't reach 5 also, you can make it 0. That's how we design. Okay? So this is how you are going to convert analog to digital. So if the pressure comes, again the sensor is going to generate some kind of a wave here, which will be decoded by ADC to get some value like that. From that, we will put a parameter. If you put 10101, what will be the value? BCD. CSE, IT or many. I think CSE IT should answer this. I said if you're not getting, raise up your hands. Not when I ask the question. Okay? Fine. I just asked, what will be the value of this? No tries from many guys. Don't know BCD or don't want to. If don't know BCD, tell. You don't know BCD. Okay. BCD is a kind of a code which, fine, that's fine. If you don't know something, any term, please raise up your hands and just ask. Okay? Okay? If you know all this thing, only you can do your project or final. This is very important. BCD is a very important for, it's a kind of a slogan for embedded engineers. If you don't know BCD, it's very hard to work in embedded. Okay? So BCD is a kind of an form where you write 84, 21, 16, 32. You'll be going in this way. Multiple of 2's. Okay, so if you fill some value like this, 10, 10, 10, you should add 32, 8 and 2. 42 is the decimal value. 32, 40, 42. Okay. This is for example. I'm just giving it for example. Nothing related to that. Got it? Readouts. Still, if not, you have to know this. Any project at any level, either you are a fresher, junior software engineer, or you are a senior or an architect, you should be very thorough in this. This is how we convert. With BCD, we are going to convert the analog signal into digital signals. Okay. So, what is the value of this? Good. So, I'll be writing a program. If this value, if it is greater than 32, then start spinning. So I will read the ADC value, get this value, and I will check my X is it greater than 32. My X is 21. It's not greater, so I will not spin. So this is how we will simulate. We'll insert the ADC value, either a function generator. I think we should have heard about function generators. If not, it's kind of a waveform generator. Just give out the waveform. Whatever you want, you can give that particular waveform. We will give it that way and get the ADC, and we will just simulate it that way, each and everything. Any doubts here on simulation? Okay, good to go. Medical, I already said. Apart from the medical chamber, we also use defibrillators, endoscopies, and then blood warmer, and then what else? Sugar meter, BP checker, digital BP checker. So everything comes under the embedded medical device. Fine. Aerospace, obviously everyone should know. So I don't want to talk much about aerospace. You can simple example GPS. Okay, I'll close with that. I don't want to explain much on that. If you want, I can explain, but it's time consuming. Okay. GPS, getting the altitude, getting the this what do you say, latitude, longitude, and then you will just calculate what height you are and how long you have to travel, how long you have to get down. That things. Okay. Coming to safety and security, again I said the fire alarm and then this paramedical stuff. Energy, again your digital meters in your home. Hope you are seeing. Digital meters. Digital energy meters. Simply should know. Digital energy meters and then trippers and voltage calibrators. If you go to the Ennur grid, Ennur power station, you can see a big room. There, everything will be monitored precisely, and there will be a display going out. This much energy is going out. This much energy is coming in. These are calculator, and displayed using embedded device. Process control, as I said, this medical chamber, ingredients, adding, that is a process. And washing machine is a process control machine. So each process should be done in after one stage. Okay. Manufacturing, same guy. Storage, your hard disk or your server. You can say a server is the best example. You have that is server. So you have to make. So even that is an embedded device. This will just monitor what's coming in, what's going out, what to store, what to throw, when to alert that memory is full, or when to give these things, everything. Telecommunication, she said mobile. Networking, again, servers and routers, those stuffs. Semiconductors, nothing to say about it. Obviously. But it's already okay. Any doubts? So whoever have a passion or intention to be an entrepreneur or a boss of their own, forget this. You have this many options in that, and if you stick to any particular thing, you are the boss. Ready now? Yeah. Recently in embedded industries, so whichever industry you go, you can choose a medical industry, you can pick automotive industry, you can pick HCL, you can pick Bosch, you can pick Tata Lexi, Siemens, anything, whatever embedded thing, embedded companies you are going in, they are now started diverting towards something called IoT. Everyone, correct, Internet of Things. How many of them hear about this? Internet of Things. You know, you hear. One. Okay. So Internet of Things is nothing but linking different perspectives of devices together. So coming back. Wait. If you are just going to link these guys, it is the Internet of Things. If I want my car, whenever it is started, I want a message from the car. And recently you can see you can start our car using a mobile. In the apps you can see. And you can get where it is going, where it is coming. If you are doing that, it is, and then I am doing with telecommunication. This is an Internet of Things. Okay? I personally have done one project in Internet of Things, which is we did home automation. So we just merged the phone with security system, with the GSM and GPS. So this is the kind of Internet of Things. Even your washing machine, mostly now Internet of Things is everything is based around cell phone, because it's with everyone. So all the Internet of Things is concentrating as the base as a cell phone, and they are making Internet of Things as well. And this is one of the highly wanted qualifications which all embedded companies are seriously looking at. So I just advise if anyone having plan to work on embedded systems, please choose IoT. But your concept should be big. It should not be just like I switch on my AC with a phone, I switch on my washing machine. This is gone past. You should do something extra. You connect your server, you get something different. You have to mingle many components. You can choose like this. If my electricity bill goes beyond this, I'm just going to get a ping on my mobile. That's a good point. But at the same time, how it should also give us how we can reduce. A suggestion. That's where your networking comes in. Okay? So you communicated energy, telecommunication, network. So how the network comes in there? You have a database which is nothing but a storage where you have certain fonts. So it has to take some fonts. I think your bill is high due to your AC power. You just have to send from the server. So think some crazy stuff. If you are how crazy you are thinking, how big you are coming out is how you are getting into environment. Okay? But you should be fingertip on technology. If you want to survive in the embedded environment. Fine? Any questions? Any questions? I don't feel the interaction. I'm just pulling you out. No one is coming out. That's why I requested PGs to come in. Actually, you are not in the picture. I want you people to come in here to ask questions. Or then I will put a group discussion. Everyone has to talk there. If no one is voluntarily coming out, then it will go in a different event. Okay. Then I will choose another 1 hour. Next. Okay. So as I said, I showed this slide already. Okay. So processor, controller, SOCs. Team 6. Please explain difference between 1 and 3. We can discuss with you. That's why we formed a team. There is no discussion. No points to discuss. Okay. Come on. Any volunteer? You can choose. Not only you. Okay. Okay. This is I can say this is a secondary point, but you missed a primary point. This is also not actually correct. Both works on architecture, because even in SOC you have a processor or a microcontroller which has an architecture. But obviously, whatever you said, the second point, which is a circuit, that's true. You have a circuit above the microcontroller in the SOC. But again, is there any other thing you want to try? If not, I will choose. I didn't ask this team much questions. Last bench. This bench. That team I want last bench to answer this. Any PGs, please. want to try? You want to try? They didn't answer it. Maybe next time.
So in processor will be connecting external flow components. In SOC, even in SOC will be connecting externally and packing it.
Super. That's a very good answer. What is a processor? What is your name? My name is Karthik. It's like an answer like that, but it's good. Really good. So, as she said, a processor is also having an external peripherals, whichever I say, ADC, DAC or timer or RAM. SOC is also having in a similar fashion, but the major difference is it is a packed one. And SOCs can have processor or microcontroller in it. That is another one. It can have either a processor in it or a microcontroller in it. It's up to you. Okay? Okay. Same son. You want to try? You want to try? Wait, I will ask them. If they are not, we will go try. Guys? Okay.
Processor, it doesn't have limited memory. The controller has limited memory. Just that.
Microprocessor 8086.
Controller.
Okay. I know this particular line is there in the book. As if I remember, if my memory is good. Okay. That is one of the point actually. Actually, the controller is already the answer of SOC comes to the controller. Again, he is a package. Okay. Whatever she missed one major point that made you to answer this way. Okay. This has everything also packed, but not enough. Here, it also has packed externally with enough memory or enough peripherals. Anyone got this? Or still? No? Please raise up your hands. Please. I know. Okay. So, a controller, if you see, it is also a kind of an SOC. What is an SOC? It has everything packed inside. All the things will be packed inside, and it will be a single chip. Okay? Controller will also be in the similar fashion. The only difference between them is the availability of resource. Say in the controller you have only 2 ADC. In SOCs you will have 4 or 5 ADCs. VLSI should know this very well. Usually when you do Xilinx or Spartan, right? So whenever you do that, you will be adding up the things and you will form an SOC. That's what the VLSI really does. Mostly VLSI people work on SOCs, as if I know. If I'm wrong, then sorry. If not, please tell me if I'm wrong. I will correct myself. Okay? So that's an SOC. SOC, you have a variety of options. Even in my controller you have, but the cost of the controller will be increasing if you keep expanding it. But instead, SOCs will have different components together in a cheaper way, and they will fix it in a complete piece, one piece. And SOCs are majorly used in non-bare metal development, which is RTOS development. How many of them know RTOS? No? Real-time operating system, at least OS, CSIT. Where are you? You have to know this. What is OS? Yeah. What is an operating system? Okay, lot of answer. So I'll pick. That is a good idea. You are saying same. Okay, fine. If it is in the book, then I accept. Okay, fine. OS is nothing but multitasking system. Okay, this is the first word should come when I say OS. And when you come in the perspective of an RTOS and the OS, RTOS is event-based system, OS is time-based system. I'm just rotating, sorry. OS is time-based, event-based system, RTOS is time-based system. Okay, fine. Any doubts here? What is event-based? What is? But you should ask me before I ask. Okay? Fine. Event-based. You click your mouse, a Word file opens. If you click the shutdown button, it shut down. If you just move your mouse, it is moving. And if you have a writer, you know digital writers, right? So if you write there, then only it acting. So you have to give an explicit event to make the RTOS run something. Okay? If you move a mouse, it is very simple to see, but what's happening inside is a very deep process. It will go into embedded as an ADC, we'll capture that, we'll get the location, we'll compare from the previous state to the current state. Is it moved from left to right or right to left or top to bottom or diagonal on a four quadrant? Then we will decide which way it will move, and then we will give it to the application. We will have a framework below that, middle there. We will give it to the middleware recognize that, okay, this is the event, give it to the application, then application will choose which pointer form we have selected. Someone will have arrow, someone will have horse running, someone will have rotating tab. So the application will choose which form it has taken, and then give the command to move from left to right. So single move has this much code to do. And developing this piece of code, imagine how long it will take just to move the code. Fine. Okay, I deviated, but I just want to know what is the internals inside there. So you will get a feel how it is happening really. Okay. So this, whenever you do some event, then only the system will react. This is called event-based system, which is a normal desktop OS. An embedded-based RTOS system is time-based. In this time, it has to be done. Coming to again this medicine chamber. Okay, I mix 2 mg within 2 seconds. We will put, and then within 3 seconds 4 mg of next ingredient. Or coming to the discovery factory, food factory. If you see, there will be a precision. So at this time, some kind of an arm should take and pick and place the thing. This is event based. At this time, your arm should be there, should go down, open the wall, suck the whatever the thing is, come back within this time, put it, so that if it miss the time, your content which is going in a conveyor will keep falling down. Can you imagine this visually? Just to what happened? Okay. Okay. So this is a time dependent OS, which we call as real time OS. Even this OS and that OS are similar, but only thing is this will be closely going with the time. RTOS. They don't care about the time. If you give, I will work parallel. showing you what picture you are having to. There will be passive, kind of a passive system, OS. Got this? Do you even have doubts on OS and RTOS? Till. No? I believe you got it. No? Yes or no? No doubts. Okay. Fine. SOCs, mostly we will put this real-time OS. Means they are a high performing, high accurate and highly high-speed controller. You can say controller. SOC is also a controller. The system on chip is nothing but you have a controller inside. One of the example of SOC is your i4 processor. Quad core, dual core. So you have packed 2 or 3 controllers inside one SOC, and you will do you will dedicatedly give one processor for one task and one processor for another task. This is how you bring in the multitasking. Multitasking, can anyone explain? Lost. I don't know. How do you see it? Okay, fine. Last. Good. So if you are working, yeah, thanks. So if a processor is going to do one or more many tasks simultaneously, I want to stress this point, simultaneously. The real fact is, it is not simultaneous. They are only happening in sequential, which is handled by a thing called scheduler. Scheduler is a software entity which will give only 20 milliseconds for each task. So by this, it will fool the processor, assuming that everything happening as sequential as well as it also fools us. But nothing is happening sequential. Nothing is happening simultaneous. Everything is happening in a sequential way. So 20 microseconds, think how small it is. This is 1 second. Go back. In that second, your task will be running. You're moving your mouse. Imagine, if you're coming to your desktop PC, you have your screen first. Okay? Then you move your mouse. As well, there is a clock running in the PC. Okay? And also there is a time display. Actually, display itself is a task. Whatever you see in the screen is a task. The picture, wallpaper is a task. And the time is a task. You are moving your mouse, it's a task. Imagine around 5 to 6 tasks running at a time on an ideal PC. But no one is interrupted between. They are going in a very smooth way, which was clearly and carefully done by a scheduler. It will give display 20 seconds, 20 microseconds. Then you will go for mouse 20 microseconds. This. So it will be slots 20, task A 20, task 2 20, task 3 20, task 4 20. So in this way, see how many 20 microseconds we have for 1 second. 1 second is normal for us to visualize. So you have more than thousands of 20 microseconds. This is how your task, your mouse movement is properly handled with other tasks, so that the thing is not. Sometimes you can see system get hanged. At that time, what happens is some small, virus. They say virus, something, malware. What they do is they will not let the scheduler to schedule other tasks. This is the virus. It will destroy the OS code, the code which the scheduler code. It will just erase that code, or it will hold the processor and hold. I will not leave the processor. That's why sometimes your PC gets hanged. And again, to know the exact reason, you want to know the priority, scheduling, priority inversion. There are many things on it. So, but our class is not to that. Just to give a pinch of what is an RTOS. So you can feel how embedded is really good. Fine. Gotcha. Okay. So with that, we are done with okay. With that, we are done with the basics, introduction, understanding, and knowing deep in of embedded. Any doubts till now? From on now, I will not tell what is embedded. I am just going. I believe you people are expert to imagine, understand embedded from this point. If not, please tell. I will randomly pick you guys. Fine. Shall we move to the next? Okay. Fine. So this is LTC 2148. What do you think this is? Who is? First line says that. Okay. Still no answer. Okay. So I want to ask you the thing. Fine. So this is a 32-bit microcontroller. What is 32-bit? Team 2 choose that. Whom to choose? Team 2. It is team 2. Team 2, team 2. Sorry. Choose which team to answer this. Fast. Even this you are thinking. 4. It is 4. 4. Even this team. Okay. What is this 32-bit? Explain so that everyone can say, because you are me, but others are UG, they don't understand.
So 32-bit,
32-bit, a lot of apology. Choose another thing. Anyone from that team? I explained 8-bit somewhere in my third slide or fourth slide, not in the slide, in the board. When I reach third slide. Vijay. Assuming 32-bit? 32-bit? Ella 32-bit le degree adha porpa maattinga. Correct. What is that 32-bit? Size of? Good. Okay, first. Okay. So 32-bit is the memory layout. Okay. So if I say 32 KB, which team? Which team? 5. Where is 5? 5. Okay. Team 5. Please. How do I have 5? But team of the team, another team, both Team 6. What is this 32 KB on chip static RAM? Yeah. 32 KB. Up. Whatever, give a try. Doesn't matter. No one is going to do it. Correct. That's for the explanation for RAM. What is 32 KB?
storage space of the
How this 32 KB will be arranged?
8.
Okay. At least you said that. That's good. What I said is right, for an 8-bit architecture. Here it's a 32-bit architecture. Means 32, 32, 32, 32, 32. So the total bits we have is 32 into 32k. Good. Just give me the answer. 32 into 32k. Give me the answer. Okay, I'm not validating it, I'm accepting as it is. So that's the bits of memory it's having. Nothing but if you say in the VLSI perspective, that much CMOS switches, correct? Right? VLSI. Each memory bit is a CMOS switch. It will hold either 1 or 0. Correct? So as you said, X, 32 into 32k CMOS chips are arranged in a row, in an indices or something, whatever you say, to form a RAM. Getting? So say this size is 32-bit and this is 32k. So you should know the value of VLSI from this. This much big CMOS chip is this small. That's the power of VLSI. If you just want to really value this. Have you seen the systems in olden days, whenever it was? You know how did they do this CMOS chip switch in the older times? Anyone? No or no? Okay. Cathode tubes. The tubes will be this much big. I got a WhatsApp message 3 weeks back from IBM. They were loading a 512 MB of hard disk, which will be this much big. 3 people will be pushing. So we used a cathode ray tube that big to form a big memories. Nowadays the innovations and reinventions got this small. So we use a cathode CMOS switch. Is there anything new coming up other than CMOS switch? FinFET. What is that? Double gate is also again a CMOS. Okay, so you have two CMOS together and 2 gates. Single CMOS is 2 gates. FinFET. What is the purpose of that 2 gates? What do you do with that? 1 gate is enough to trigger it, right? Synchronization issues will come. With 2. So you will, but it will take too much power, right? You have to give 2 leads to threshold. Coming parallelly. Is it divided voltage or equal voltage? 0.7, 0.7, 0.25, 2 gates. Okay, good information. Thanks for that. Okay, then it's going to go micro. Now I just showed at least like this, it should go like this. Okay. Fine. Okay, so any doubts on this, understanding this 32 kV, how it will be arranged in the microcontroller or microprocessor? Any questions? You understood this, right? So our next class is going to be based on this. Only this pattern. Okay, if you don't understand this pattern, please ask. I'll be talking much on this perspective. Means I will give examples only with this obviously in my second class. What else? inch. Okay. 2 ADC 14 channel. Who want to try? Or I want to pick. Try or think. Even that I should pick. No idea. That's great. Go to Karthik. Never. Open up the screen. That's the good thing. 2 ADC 14 channels. It's so clean, right? Am I in alien language? You don't have to say it together after. Nobody say it. I get that. சரி இனியே ஒருத்தருங்க இந்த பையன் அது மாதிரி எவ்வளோ சொல்லுவோம் what do you get out of that 2 ADC 14 channel 2 man okay, so as I said, we have 2 ADCs and 14 channels. So each ADC will be having 7 channels. So what is 7 channels? What do I get out of the 7 channels? I can give 7 analog signals to that individually. So I can just monitor 14 analog signals and validate them for my processor. Any doubts? Doubts? That's what. Just raise up your hands. 2 ADC. You got what is ADC, right? When I explained that. Analog to digital. So if you give the analog waveform 1010, it will convert. Correct? Here you have 2 dedicated ADC, means you have 2 individual ADC chips. Okay? I'm not just going here with microcontroller or this thing. In general, I'm just saying. Okay? So there will be 2 ADC chips. Will have 7 leads out. Means this is your ADC. 1, 2, 3, 4, 5, 6, 7. So in each lead, I can connect one sensor. Getting? So 7 sensors I can connect at a time. Okay? So 14 sensors means I can monitor a lot of things. For example, I use this when I was doing a security system. We want to monitor all the doors in the house, all the windows in the house. Okay, so we use this ADC channels. So we have 14, right? So in some things we have 24 ADC channels. So in each we will give each magnetic or proximity sensor. A magnetic sensor is nothing but there will be a magnet on the side and there will be a magnetic. It's not an inducer, detector, magnet detector. So whenever a magnet comes in, this will just close the switch. Imagine like this. This is my switch. Here, this is not the exact thing, I'm just explaining. Here you have a thick metal which a magnet can absorb or attract. Okay? When I bring a magnet near, this will be attracted towards this, which will close this circuit. Getting? Can you imagine how it's working? So in this way, if I'm giving plus 3 volt, when the magnet is not there, I will get 0 volt here. It is not passing since it is open. When I bring the magnet, this will close and I will get a 5 volt here, which my microcontroller will detect. When we will just monitor each pin, we will monitor whether I am getting 5 volt, 5 volt, 5 volt. When I get the 5 volt, immediately I am going to change my algorithm. I got this. I am going to do. How we place this is, you have the door and you have the, frame. Okay? Here we will fix the magnet, here we will fix the magnetic sensor. So when the door is closed, we are full. Means I am getting 5 volt. When this 5 volt is detached, we say the door has been opened or braked and we are off. Got the design perspective? Just get this design ideas. So you have to design your project. Any doubts here? This is how all the sensors will work. Any sensor you take, either we are going to monitor the GPIO or we are going to monitor the ADC, either through interrupt or polling. I'll say what is interrupt and polling in a second. Okay, but not on this one. Interrupt and polling. If I missed, just inform me. And I want any one of you just to note down whichever I say in the next class, please note it down and remind me if I missed. Okay? Got this sensor thing, right? So in the same way, as I told the ADC, 0101, we will just getting that value and we will just load it. We will see whether this value reached. When it reached, we say something have happened, put it down. The simple example coming again, I will say you one thing. Smoke detectors. If you see a smoke detector, anyone know how a smoke detector works? Any? No? Some? No one's in the ball.
No.
Okay. Huh? Okay. Usually there will be a cavity. Okay, a cavity is nothing but a closed space, and you have a this is the closed space, and you have an IR emitter and receiver here. Okay, so IR will be going this way. So this is a void space. Nothing will be here, just air. So what we will do is we will connect the receiver end to ADC. Okay. So whenever this IR is going to send this IR rays usually get scattered. When there is high moisture or humidity or density of the air is high, then IR is going to interfere or distract it. Fine. When there is no smoke, I will get the full power of IR. IR is nothing but electrons, if you are good in physics. Okay. IR is light is nothing but emission of electrons. Okay. So this will give electrons which the receiver will detect and it will generate voltage the other side. And I will keep reading this voltage in ADC, that is analog to digital, converting it to 0, 1, 0, 0, 0. And I will just reading that value, keep on reading that value, and I will understand what is that value, whether this value is dipping down or ticking high. Ticking high is not a problem. Dipping down is a problem because if the fire happens, you know how the smoke will be. Smoke will be very dense. You can't see the other side, right? It will be heavy, dense particles will be high. Okay, that will be loaded here. So my smoke is here. At this time, your IR cannot pass out the other side. You get interfered and blocked. So what I will get is in the receiver side, I will not get any ADC value. I will be getting 0, 0, 0, 0, 0, 0, 1 or even 0. My ADC is down value. So I will say I found there is a smoke happened in this particular sensor and I will allow it. Yes, got this. This is how your fire alarm is working. Simple concept, simple physics. This is where the innovation also comes in. You don't want to, you know this moon story? US moon, writing in the moon. No one knows. Okay. Actually, when there is Cold War, you know Cold War, right? I think everyone have gone through history. So in the Cold War, America and Russia were just fighting, not directly, empirically. Okay, so they want to set their foot in moon. Whoever does first is a kind of pride to them. So America launched rockets, but first rocket was launched by Russia, unmanned. That's why they didn't get the name. America sent a man to the moon. First, obviously a dog, not to a man from America. So US. So what happened is they want to write something in the moon. So America were just doing a lot of research because if you go into the space, your ink fluid, right, it loses its property. It will not hold together, but it go apart because there is no gravity. Correct? So they were just researching all this. They were putting some $6 billion or $4 billion or something. I don't know the exact cost. They are putting a big research, and they are trying want to write it to something, and at last they found a pen to write in the space. Even in Nanban you can see, I think, right? But what happened in Russia, he took a pencil. So simple. So the innovation doesn't matter when you put money. Even if you think simple, you can yield big. This is the difference of innovation. Some people will think, I want to hit the rock, kind of an innovation. Doesn't matter. Simple, small innovation. Even Kalam. Recently I heard this. India have launched a rocket. I don't know which rocket. Sorry. They launched a rocket, and unfortunately, after the rocket was placed in the orbit, antenna sensor was failed. So the whole you heard of that? Okay. So whole research Indian ISRO, they're planning either we want to send a man to the orbit or we want to send automatic robo spacecraft to the satellite, and we want to do it. So they estimated the cost, it was going somewhere billions or something. So Kalam was there, and he told, if the sensor is not working, why you want to go and repair it? Keep the antenna towards the sensor, where it is pointing. If the sensor is pointing here, just keep the antenna here, it will receive. Why you want to send a person and do? This is what Kalam gave a plan. This is what we are using in the dish TV. In dish TV, a person will come here and you will just see. That's the idea of Kalam. Before that, the idea is you want to place an antenna, that's it, just like a Doordarshan. Some aluminum. Now you want to keep it in a dedicated direction, then only you see. So by this, they reduce the cost of research rather sending an unmanned thing or something. Okay, so think simple, you can do many things. This is for your second thing, this point. Okay, DAC. How many know DAC? That's all. Okay, so nothing but the reverse of ADC. So nothing to tell about it. If I give digital, it's going to give me waveform, the reverse fashion. Where do we use this? PlayStation. PlayStation. What is that? Okay. That's only a telephone department or something. Okay. So as she said, that's one of the things where you will send the digital signals. It will be converted easy. Okay, it will be converting into analog, and it will be sent through the dual wire. And I know somewhere dual wire, I think. It will go in the analog fashion. The other way you are just going to see. This is the same fashion you are going to how your optical cable is also going to do. Hope everyone know optical cable how it works, right? Fine. Okay, other things, RTC, you know what is a real-time clock. So obviously it is a time-based system. So the timer and RTC are a high priority in controllers. Not a controller, processor or SoC. Okay. Any doubts till now? Okay. So next thing we are going to see is ZigBee. How many of them hear this? Good. Tell me. Okay, whatever you heard, tell. What example? Was
just like searching for objects. So I came
anyone else? Okay, ZigBee is the kind. equivalent to Bluetooth. It's not the next generation or the below version of Bluetooth. It's equivalent to Bluetooth. It's a wireless transmission device. Wireless transmission device. Okay? So these are the blah 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 blah. Whatever you want, you can note it out. I don't want to explain these things. Just, I'm not an ECE guy and I don't want to care about this. Whoever ECE, please tell me this. Yeah? Any questions? Okay, so we don't want to know the specification. As an embedded engineer, we don't want to know, we want to know only what gigahertz, what kb, 250 kb or latencies, those things only in the design phase. In the implementation phase, we'll never care about this. And then it will arise in the debugging phase. Debugging phase is the end phase, almost. Okay, or in the development on the go. I want to stress this particular thing. Latency. Who on your tribe? I don't know, you said Gajni Maro to get there. Yeah. So the latency is measured, or it can be defined the time it takes from the start to the end, from the source to the destination. How long it takes is the latency. Easy, yeah. Easy, antenna, waveform, we should be knowing this latency word. Okay, so this latency is a very important term in embedded because this is going to affect your performance, your timing. As I said, embedded is a time-based system, and if I miss that time, I'm going to mess up with something. My device is going to mess up with something. Again, we have a safety critical system and non-safety critical system in embedded. I'm talking about safety critical system. In a safety critical system, if the latency is too much, my performance is going to affect, and I'm going to mess up with my client or end user. End user is nothing but if the mobile is the device, I'm the end user. Okay? Okay? Fine. So we are in very important phase. So from here, from this point, we are starting our project, this workshop project. And each, as I said, there is a dedicated team and there is a captain. And the basic block diagram of our system. I don't want to go in a variety of systems because this is not a final year project. This is a workshop and I can't spend much time on different technologies. So I want all you to go in the same technology. That's why I just choose this kind of system. Okay? System 1, ZigBee. This is 2148 or your PC, whichever you choose. Again, same. So you have two ends. How do we connect ZigBee? Three. Okay, fine. Okay, team 3. I want one person come out. Volunteer and then I review. I want one person to explain how we will connect the ZigBee and use it. Team 3. Anyone? Come on.